Humanity has long dreamed of observing life on Earth from space, but how well could astronauts actually see animals without technological aid? The human eye is an impressive organ, capable of detecting light, color, and motion over vast distances, yet it has limitations. From low Earth orbit, astronauts aboard the International Space Station, ISS, orbit our planet at an altitude of about 250 miles, 400 kilometers. At this distance, they can see large land masses, oceans, and weather systems with the naked eye, but individual animals are far too small to be visible. The smallest objects that can be resolved by the human eye depend on the distance and contrast against their background. Under ideal conditions, humans can distinguish objects down to about 0.02 degrees or 1 arc minute. However, from space, even large animals like whales and elephants would appear too small to be seen without magnification. The Earth's atmosphere also affects visibility. Layers of air, dust and clouds can obscure fine details, making it difficult to distinguish smaller features from space. Even if an astronaut had perfect eyesight, atmospheric distortions would prevent them from spotting individual animals with the naked eye. The sheer speed at which astronauts travel around the planet also complicates observation. The ISS orbits Earth at approximately 17,500 miles per hour, 28,000 kilometers per hour, meaning astronauts only have a few moments to glance at a specific region before moving on. Despite these challenges, astronauts can observe large-scale animal movements in some cases. Massive animal migrations, such as herds of wildebeest in Africa or flocks of birds flying in formation, may create visible patterns. From space, such movements appear as dynamic shifts in terrain rather than distinct animals. Seasonal changes, such as the shifting colors of forests and grasslands, can indicate the presence of migratory species. The Great Migration in the Serengeti, for example, involves over 1 million wildebeest and zebras moving across the plains, creating visible disturbances in vegetation. Some animals leave visible trails or paths that can be seen from space. Elephants, for instance, carve well-defined pathways through dense forests and savannas, which can be detected from high above. Similarly, herds of bison in North America may create noticeable disturbances in grassy landscapes. These trails, while not revealing the animals themselves, provide indirect evidence of their presence. Whales, the largest animals on Earth, present another interesting case. While individual whales are not visible from space, their movement can sometimes be detected through disturbances in water. The wake of a whale swimming near the surface or the presence of large groups of whales in feeding areas can create surface patterns detectable from orbit. Plankton blooms, often associated with whale feeding grounds, are visible from space, indirectly indicating the presence of marine life. Some large marine creatures, such as sharks and manta rays, also interact with their environment in ways that leave visible marks. If an enormous school of fish or a pod of dolphins causes ripples on the water's surface, the patterns might be observed from space under perfect conditions. Another factor influencing visibility is contrast. Animals that blend into their surroundings are much harder to see, even at close range. In space, animals with high contrast against their background, such as white Arctic animals on dark ocean ice, might be more easily detected. For instance, polar bears on sea ice may be difficult to spot directly, but could be inferred from their movement patterns or tracks left in the snow. In some cases, flocks of birds or large colonies of penguins create distinct patterns that can be observed from space. Large flocks of flamingos, for example, can tint shallow lakes pink, making their presence detectable from orbit. The migration of monarch butterflies, spanning thousands of miles, is invisible individually, but might be observed in the form of shifting forest coloration, where they gather in dense clusters. While individual animals are too small to be seen, their impact on the environment is often noticeable. Herds of grazing animals alter landscapes by consuming vegetation and trampling the ground, leaving behind trails and worn-down paths. These changes can be observed from satellites and sometimes even from the ISS. Similarly, large bird colonies, such as those of flamingos in shallow lakes, create noticeable color changes in the water due to their sheer numbers. Large-scale nesting sites such as sea turtle rookeries leave patterns in sandy beaches that may be visible from space. Some seabirds, like albatrosses, have extensive foraging routes over oceans, which could be indirectly inferred through oceanographic changes caused by their feeding behaviors. Another fascinating phenomenon is bioluminescence. Some marine animals, such as certain species of jellyfish and plankton, produce light in the ocean. In extreme cases, vast blooms of bioluminescent plankton can be seen from space. These glowing waters can be an indirect indication of marine animal activity. Astronauts have reported seeing large glowing patches in the ocean at night, though the exact sources are often difficult to determine without instruments. The mysterious Milky Seas phenomenon, caused by bioluminescent bacteria, has been observed from space and hints at unseen marine life beneath the waves. Squid and some deep-sea fish species also produce light, though their glow is too faint to be directly detected from orbit. Animal behavior that affects large-scale geography can also be observed. Beavers, for example, create extensive dam networks that alter water flow, creating visible patterns from space. Similarly, termite mounds in Africa form distinct circular formations that can be seen from high above. The activity of animals reshaping their environment over time leaves visible marks on the planet's surface. Prairie dog towns in North America, covering vast areas with burrows and tunnels, create patterns that can sometimes be observed from orbit. Even ant colonies, when densely packed, can produce distinct changes in vegetation that appear in satellite imagery. One of the most striking examples of animal presence visible from space is the nesting colonies of certain bird species. Emperor penguins, for example, gather in massive groups on Antarctic ice, forming dense colonies that leave visible stains on the ice due to their guano. These colonies are large enough to be identified using satellite imagery, though they remain indistinct to the naked eye from the ISS. Human structures associated with animals can also be seen from space. Wildlife reserves, farms and fisheries create patterns that suggest the presence of animals, even if the animals themselves are not visible. Fenced enclosures, roads cutting through migration corridors, and artificial watering holes appear as clear signs of human-animal interaction. Cattle ranches and dairy farms often feature geometric layouts, making them some of the most noticeable animal-related structures visible from orbit. The circular grazing patterns of livestock, caused by irrigation systems, can be striking when viewed from space. Ultimately, while astronauts cannot see individual animals from space without technological assistance, they can witness the effects of animal life on Earth's ecosystems. From mass migrations to bioluminescent blooms, the presence of animals manifests in ways that become visible even from orbit. The study of these large-scale patterns offers valuable insights into the health of our planet and the intricate relationships between living organisms and their environment.